So here is how we complete the square. Let's take a very simple quadratic expression. What we're going to do is to write that as something squared. And we'll also need a little bit at the end over here. So we've got x squared here. How can we get x squared? Something times something has to make x squared. That's going to be x times x. We're going to put a number in here. A number is going to be multiplied by x there. A number is going to be multiplied by x here. It's going to be the same number because it's going to be squared. This is called completing the square. So this expression has to be the same as that expression. So this number is the same as that number. So what can be put in there that when we have two of them makes 4, but it's obviously 2. So now if we do x times x, that makes x squared. 2x plus 2x makes 4x, but then we've got 2 times 2 to make 4, but here we've got 9. 2 times 2 is 4, but that says 9, so we have to add 5. So now we can write this as x plus 2 squared plus 5. Let's try another example. So this time let's do x squared plus 9x minus 3. So we need to write this as x and x because x times x is going to make x squared. Half of 9 is 4.5, so this has to be 4.5, 9 over 2. So there's a plus 1, there we go. So what have we got? We've got x times x is going to make x squared. 4.5x plus 4.5x is 9x. And then we've got 4.5 times 4.5, that's 20.25. So we've got 20.25, but we actually want 3. So we need to take away 23.25. That's because 4.5 times 4.5 is 20.25. 20.25 take away 23.25 is minus 3. So this whole expression becomes x plus 9 over 2 squared minus 23.25. Now let's take a slightly harder example. Let's do 3x squared plus 17x plus 4. Well, this is more complicated because we've got 3x squared, so let's take that 3 out as a factor. As a check, 3 times x squared, that's 3x squared. 3 times 17 divided by 3, that's 17. 3 times 4 divided by 3, that's 4. So now we need to complete the square on just that bit inside the brackets. So we can have a larger bracket there. Everything is times by 3. So it's still going to be x and x. That's because x times x is x squared. We've got 17 over 3. We need to halve that. So that's 17 over 6. Let's just check. X times x, that's x squared. 17 sixths plus 17 sixths, that's 34 sixths. 34 sixths is 17 thirds. That's okay. And then we've got 17 over 6 squared. So let's just do a little bit of work down here to check. 17 over 6 squared is 289 over 36. We haven't got 289 over 36, we've got 4 thirds. We've got a very noisy motorbike just going down the road. We've got 4 thirds, so we've got to put something in here, 289 over 36. What do we have to take away from 289 over 36? To make 4 thirds. So if we solve that equation, then we get y is 289 over 36 minus 4/3, which is 241 over 36. So there's a minus 241 over 36 that goes in there. So let's just check what's happened now. Let's do it in green this time. X times x is x squared. 17/6 plus 17/6, that's 34/6. 34/6 is the same as 17/3, so that's okay. 17/6 times 17/6 is 289 over 36. 289 over 36 minus 241 over 36, that is 48 over 36, and 48 over 36 cancels down to be 4/3. So to summarise now, what we've got is 3 lots of x plus 17/6 squared minus 241 12. Now you may be wondering why that's a 12 here and that was 36 here, but remember everything was times by 3, so it's 3 there. The 3 divided by 36 is 1 divided by 12. So I've made a little bit of a mess of this. This bit below the line here is just some working, and this bit is the completing the square bit. So here I've written it out a little bit more elegantly. Always a good idea to check your work. So let's take, for example, x is 1. If I take x is 1, 1 squared is 1, 1 times 3 is 3. So 3x squared plus 17x plus 4 is 3. 17 times 1 is 17. 4 is just 4, so that's 24. Let's do the same value, x equals 1. Let's put that into our answer here. So I'm going to get 3 lots of x plus 17 over 6 squared minus 241 over 12 equals 3 lots of 1 plus 17 over 6. So that's 3 times 23 over 6 squared minus 241 over 12. 23 over 6 squared is 529 over 36. 529 over 36 times 3 is 529 over 12. So it's 529 over 12 minus 241 over 12. So let's do that. That works out to be exactly 24. So that's nice, because we've got 24 here and we've got 24 here. Now, one of the uses of completing the square is to be able to solve equations. Let's think how we could solve this equation. We know that 3x squared plus 17x plus 4 can be written like this. So now we can solve this equation. This is easier than the original equation. In this equation, x appeared twice. In this equation, x only appears once. So we can just do inverse operations to solve this equation. So let's add 241 over 12 to both sides. Let's divide by 3. And then let's take the square root. So it's the square root of 241 over 36, and just remind ourselves we can have plus or minus. So therefore x is plus 241 over 36 minus 17 over 6, or minus the square root of 241 over 36 minus 17 over 6. They are the exact answers. We could convert them to decimals if we needed to. But the thing about this is that in the original equation up here, x is in 2 places, and now x is just in 1 place. So that makes it easier to solve this equation.